So today we are hosting our second webinar in our series on AI and the built environments. I am Christophe Lelanou, a board member of the Franco-British Data Society. Our speaker for today's webinar will be introduced by Pierre Sonal, an architect and co-founder of airc.digital. AI is currently transforming the architecture sector, and I'm thrilled to explore this topic further through our series of webinars. In our previous webinar, the first one of the series, we discussed creativity and how architects are leveraging AI in their daily work. If you miss it, you can find the recording on our YouTube channel, and we'll share all the link on our chat as well and later with you as well. And our next and third and final webinar of this series will be in 2 weeks on May 29th. It's a Wednesday as well at the same time, focusing on the impact on AI on software developments. And today's webinar is focusing on OpenBIM. But before giving the floor to Pierre to introduce the speaker, I would like to give a brief introduction to the Franco-British Data Society. So the society is a new society with the goal of promoting education on digital and data-related topics and providing a networking platform. We hope to become soon an educational charity. We welcome in our society a diverse mix of entrepreneurs, experts, practitioners, and non-expert people interested in data and digital topics. We like to explore discussion from a Franco-British and European perspective, covering policy, governance, digital transformation, artificial intelligence, data science, education, and so on. If you are interested in our event, you can follow us on LinkedIn, or you can subscribe to our newsletter. And as well, we'll share all the link on the chat. Some of our events, like today, are advertised online and free to attend, while others are more private and open only to our members. So if you like to support us as well, you can become a member of the society. And if you have any question on this, please don't hesitate to reach out for any more information. So finally, I would like to thank our corporate sponsor, Data Learning and Irwin Mitchell, without whom it would not be possible to organize this webinar today. So Pierre, you would like to introduce our speaker for today? James?
Yes, thank you very much, Christophe. It's a real pleasure and an honor to be there and to see so many of you here for a topic which is very important to us. Jaime and I are just back from Saudi Arabia. We landed this morning at 5:30 after 2 days of a summit where we presented as OpenBIM consultant the work we did on phase one of the projects there. And so we spent the last 2 days in Saudi Arabia talking about OpenBIM, the importance of OpenBIM. And today we want to sort of extend that topic and to see how AI will fit within OpenBIM, within the current framework. So I'm delighted to introduce Jaime, who is the co-founder with myself of ArcWorld and although airc.digital, which is our OpenBIM consultancy. So Jaime is an architect by training. He's been using ArchiCAD as the main authoring tool for more than 20 years, to the point that he can as well code the language that ArchiCAD speaks, which is the GDL coding. And he has a vast experience in OpenBIM and interoperability between softwares. And we will today extend that aspect of OpenBIM, so the interoperability, to AI and to see how it can enhance the way we work and we deliver the built environment. So without further ado, Jaime, the floor is yours. Thank you for being there with us.
Thank you, Pierre, for the introduction. I hope you can, everybody, hear me. Going to start the presentation now. As Pierre mentioned, we are ArcWorld. We are a group of companies and different brands that we use to provide services in the built environment. We have art design with which enables us to provide architectural services, and that complements our consultancy services and BIM management that we provide with airc.digital, which retrofit each other. The result of this collaboration generally leads to tools or automations that we first test internally, and then we commercialize in our market for other architects and designers to be able to use these tools. And we also have a branch for training and education called ARC Academy. Today, we are going to introduce the digitalization in the AEC sector, and to give a bit of a framework of how we arrived to the current situation. We are going to review a few of the stages that this digital transformation has been taken in the latest years. So the first production method that we used to have in the AEC industry was analog methods. This was very labor intensive and skill intensive, so you needed to be a good draftsman to be able to develop architectural drawings. And it was just not just the technical formation, but also to be able to actually draw by hand, which is something that not everybody is skilled at. Also, being paper-based and analog-based, the coordination between disciplines was quite difficult and often not very, very profound. With the introduction of personal computers and the first CAD applications, we started to transition to digital production methods, which of course require less labor. People working in the industry became more efficient, and also less skilled people, in the sense that you didn't need to have good hand drawing skills. You just needed to be able to learn a particular software, and the software was replicating what we used to do by hand, but without knowing generally what was the context. For example, in CAD, a line represents a line, and this can be anything that you want to represent with a line. Two parallel lines can be a wall, but also can be part of a detail of a screw, or simply design that you are starting to sketch. But the program doesn't have a context of what you are trying to represent with that. Of course, this enabled better 2D coordination because we could overlay drawings received from consultants, for example. So this enabled a bit better collaboration. The third evolution was to introduce parametric CAD with the idea of automation in this drafting process, as well as intelligent objects to a certain extent that could adapt to different dimensions or to different layouts. And of course, as well, the 3D modeling started to be part of the CAD workflow, although still the software didn't know what's the context of what you are trying to represent, didn't have information about the 3D model as a virtual representation of the building. This is where we arrive to building information modeling, which is the current state. This is based on parametric design, and as you can see in the image above from Graphisoft, showcasing the concept of BIM, the idea is that we have a central model that is not only geometry, but also contains data and is object-oriented. So the software has a context of when you are drawing a wall. It is aware that it has certain layers, it has a certain height, and a wall can contain windows, a wall can contain doors. And that is different to another object, which can be a roof or a column or a slab. And this rich model then produces the rest of the documentation required for the project, or any other output. It can be 2D drawings, it can be plans, elevation sections, could be animations, virtual reality, cost extraction, analysis of the different components. So it is a much more information-driven approach. And of course, enables as well the coordination between several disciplines, because instead of sharing drawings, that is very difficult to compare to each other, we are sharing a 3D model that we can run class detections and visually inspect that they are coordinated, and even do comments for the other disciplines to take this comment on their own model. The next step we think is going towards artificial intelligence design. So basically trying to add more complexity to the computing engine that is helping the designer in a much more interactive way that is allowed by the current trends of artificial intelligence and the power that they are able to process information. Also, we are evolving to automated construction methods. So soon the BIM model won't be just a representation that then will have to be interpreted on site, but it will be a direct translation from the model to the site by robots either printing 3D walls or automated processes in manufacturing that then produce the components that will conform the architectural design in the end, but all machine driven and automated. And this also connects to what the concept of digital twins, Internet of Things, and the metaverse. Basically, we will be able to have real-time performance of the buildings that we design on operation, and all this information captured by sensors could be replicated in what will become a digital twin, which logically will be an evolution of that BIM model that was used during the design process, and that can be a digital representation of the built asset and represent a 3D model database of the sensors that are providing data during occupation. This is an example of how complex the current environment of the building life cycle is. We have a lot of different operations, different stakeholders involved in the process of designing a building from the beginning to along with the client needs to construction, to use, end of life, and recycling of the buildings. So this concept of circularity we think is also quite fundamental, both with the concept of BIM, having a model that you can use as a database of what materials are contained in a particular building. And if this becomes a common database, then this could allow really a revolution in the way that we build and we recycle the built environment. In this context, BIM is already changing the way we are designing buildings. The traditional workflow meant that a lot of the design effort was done just before manufacturing and construction. So little effort was done in coordinating during the early stages of the project. And with BIM, we tend to try to bring all that effort to the start of the process. And bring as much information in the model as possible in the early design stages. So when we get to the construction stage, most of the issues have been foreseen in the virtual model and have been resolved before getting to site, which is where the changes or variations are more expensive to realize. In this regard, the collaborative design process is very important, and as much as possible, the stakeholders relevant to the decisions that need to be made for the final design are encouraged to be brought to the beginning of the process. So we think that people are central to OpenBIM and not just technology. In that context, there is an international ISO standard, and ISO 19650, which is dealing exactly about these matters, how to share information in the BIM environment, and how this collaboration should take place in the most efficient manner. It is based on previous British standards that started in 2007, but has been embraced by a lot of different countries. For example, in France, it's compulsory already to produce building information models for any public project that is above a certain size. In England happens the same. In Spain, they are just starting to implement this this year with they aim to have this ready for 2030. But in general, every country is realizing that building information modeling and digitalization in the built environment is fundamental to be more efficient in the way we produce, share, and archive information and access this information afterwards. Quite central to this idea of collaboration and sharing information is the use of open data formats, independent from the source platform that we use to produce it. For example, for images, we have JPEG, that is an open data format, or for documentation and text, we have PDF that can combine with images. And the equivalent to these open data formats in the BIM context is IFC, Industry Foundation Classes, which is an open 3D geometry format that also holds all the data related to the geometry. So for us, the definition of OpenBIM is the freedom that every designer should have to choose whatever platform or whatever software that is best for their particular needs. There are really a multitude of softwares that are currently used in the AEC industry, and this graphics exemplifies that. And of course, there are breaches between them. Sometimes this is in the form of an API that provides a direct connection, or sometimes it's intermediate data formats that are compatible between each other. But we believe in the idea of ISO 9650 that we shouldn't share information using proprietary formats, because then it's locked to a certain manufacturer or a certain copyright of the producer of that particular software. And therefore, we believe that IFC is central to this sharing of information in an open way, and also to be able to access this information in the future, regardless of the software version or platform. This is an example of how currently parametric design is helping with the automation of a lot of the tasks that used to be manual in the design process. As an example of the before graphic, this is a connection between Rhinoceros, which is a modeling software, Grasshopper, which is a visual scripting software that you can generate geometry by connecting nodes into different operations, and then the translation, which is automatic into the BIM model in ArchiCAD. So we are connecting three different softwares, and of course, the introduction of AI in all these processes will help to make this more efficient. In the same sense, the 3D models and the BIM models that we produce during the design process can be used to simulate real-world conditions. In this case, for example, irradiation on a facade of a building regarding a particular location, shadow analysis during a particular date in the year and that particular location of the building. This is an example of this kind of analysis done in ArchiCAD in different floors of a building that we are currently constructing in London. And the thing is that a lot of this currently depends on what capabilities the software has implemented. But we believe AI will help in driving this kind of environmental analysis and make it more accessible for the users in a much more automated way, because the way it is now, you have to have quite a specialized knowledge to be able to produce this information. This is another example. This is Eco Designer in the design software that we use, ArchiCAD, and we are seeing here different kinds of elements in the building that are being analyzed for their energy performance. And because the model contains all the data, for example, of a particular wall in this case, we can calculate the U-value according to the real material thermal performance, and therefore foresee if we are complying with the regulation. In a similar way, we can do analysis of thermal breaches and feed this information into the energy model. All this is currently manual and a lot of steps to get to the final result. So we think AI will help in putting all this together. This is another example of how currently AI is being introduced in a lot of the design software that are being used in the industry. This is Midjourney. It's a image generating environment that using a prompt, you can describe what you want to achieve, and is using a very simplified image or concept that you can model in the software, and then it will process that image and produce a result interpreting the prompt and the geometry that you introduce as a base. Here we can see the different results of different prompts, but we find that these kind of images are more for inspiration in the initial concept stage, because by the nature of the AI generation of the images, there will be mistakes, and there are things that don't look quite right. So we don't see this as a replacement yet for completely user-driven renders based on the model, but rather as inspiration. And this is how we have been using it in our projects. This is another example of a project that we are developing. This is giving different prompts for graphical styles of a render of the interior. In this case, a more stylistic or drawn effect visualization, or a more realistic on the left and more photographic. But you can see that the interpretation of the initial model can be quite different. So we can see a sky here on the right when that wasn't part of the initial image. We can see skylights here. So the AI doesn't always produce the result you want. For example, there was a glazed balustrade going through here, and it's just removed the central bit. So in a way, it can be used to produce images and inspiration, but we don't think this could be a final render that you give to your client. These are more close to a final render, but still there are mistakes. And this is just exploring different ideas for materials, and this is all based in an existing model that we are proposing some different options. Another way that currently we are using AI is to help with coding. As Pierre mentioned, we use GDL scripting in ArchiCAD to develop our own tools. And here on the left, you can see a code I put together, and then I asked ChatGPT to review that code and to see if it works properly. And then doing that is quite efficient to interpret something that you have put together and suggest how it could be developed further. But everything depends on the training or the database that the AI has been provided. So if GDL is not part of ChatGPT in general, the results that you will get if you try to generate code directly are not going to be very, very efficient, because some of the commands, for example, doesn't exist in that particular interpretation of ChatGPT. Another example here on the right is creating a regular expression that can drive the checking of information of a particular model. There is a new standard called Information Delivery Specification that is aiming to provide a machine-readable and structured approach to checking information in the models that is both being able to be interpreted by humans, but also easily interpreted by machine code. So this is where AI can connect to this kind of information that we are introducing in the model. And we believe that using IFC as a standard format for feeding building information to AI is the logical step to regularize how AI is used in the build environment. We also see the emergence of online applications, completely new applications. For example, in this case, an urban planning assistant that is driven by AI. So you can very quickly assess different options for urban design, for example. And a lot of this is driven by code compliance and databases of what the building code in that particular area needs to comply. Although we need to mention that the interpretation of the building codes is currently the most challenging problem that we are facing integrating AI, because they are not written in a way that are easily interpretable by the machine learning, and as well they are usually subject to different interpretations, and is not really systematized the way this information is produced, depending on the location. So an important step to be able to check compliance with AI will be to make the building codes machine readable in this regard.
Wait, can you hear me? Yes. It's going to be, it's
Sorry?
already 27 minutes, so it's going to be time to
Yes, I'm almost
shortly.
finished. This is another example.
We get a couple of questions.
This is an integration of AI in the current design softwares, and basically is automating tasks that the software already is able to perform by itself with help with the user. So we also think that the logical integration of AI in the design softwares is to try to help the users and not to create new tools from scratch, because all needs a framework behind to be able to work on. And just to finish, we think that there is no OpenBIM with an open mind. So let's embrace OpenAI as part of the BIM journey. Thank you.
Thanks a lot, James. That's very fascinating as well. So we have a couple of questions in the chat, and maybe I can read them as well for you. Yes. First question from Ludovic is wondering if you can comment a bit on your on the cybersecurity policy and the cybersecurity aspect of your operations.
Well, we tend to work in a cloud environment. We work remotely, so we use our own servers to develop our designs using ArchiCAD, and all the design team can connect to this server. So that's one of the strategies that we use, because we also are quite mobile and work remotely. So this helps a lot with the way we work. And to store our project information, we use Google services currently and our own servers.
Okay. And another question as well, or maybe two questions. Maybe I can connect the question 1 and 3 as well. Do you foresee that AI-generated rendering being able to provide exploitable 3D environment? Will we be able as well, like you mentioned, I think quickly, yes, metaverse and alternative world. So do you think then soon we'll be able to move around this environment you are going to create?
Yes,
and maybe a connected question is, do you think that this AI will reduce the need for technicians, especially at detailed design?
Yes. Well, for the first question, I think we have been seeing the evolution of the AI engines from the first text-based like ChatGPT to then Midjourney that was able to produce images, to now Sora that is able to produce videos. And that's why we think the logical step to being able to produce 3D model information using AI will be to follow the IFC schema. Because, yeah, of course, we could introduce AI in very different design softwares, but then it's always going to produce the geometry and information based on a proprietary closed format that is not going to be able to easily be shared with others using other platforms. So we really believe that the way forward with AI is to use this common format. And regarding the replacement of technicians, I don't think AI is here to replace anyone. I think maybe you will be replaced by someone who uses AI better than you. So I think we should understand AI as a tool, and as the computer has been a tool for designing for many years. AI is the next step. Of course, is a very big leap, but we don't think AI is going to replace anyone. It's going to be used as another tool in our tool set.
Okay, thanks. I think we are getting over time now. So Pierre, do you want to have a final word maybe for conclusions today?
No, just to say thank you very much. And just saying that there is maybe one last question, which could be the final word from Jaime. So Jaime, what is it's a question from Benjamin Blasco. What is your opinion on the use of AI to better guesstimate the global price of a building using existing database and analyzing evolution of price curve? Thank you, Benjamin. Very interesting question. So the last word is for you, Jaime.
Thank you. Yeah, I think this is a very pertinent question. In general, I think the power of AI is the ability to process large data sets. And this can be either your own specific data sets. A lot of architectural studios or construction companies are already training AI in their own data sets to produce results very tailored to their needs. But of course, if this information about pricing is publicly available, for example, in Spain, we have a government-driven database of official construction prices, it's very easy to connect that to a BIM model that has quantities and has specifications to this database of prices that can be publicly available. So the more data that we feed to AI, the better we are going to be able to analyze our designs and the built environment in general.
Okay. Michael, as well, I think you had a question as well. You raise your hand. I think I allow you to speak. Yes, Michael? No? Okay, but then I think we are maybe going to conclude.
Can you hear me
sorry.
now, Christophe? Sorry, can you announce the date of the next webinar?
Yes, of course. The next webinar is on the 29th of May, in 2 weeks. Wednesday, the 29th of May at 12:30 UK time or 1:30 French time. Trying to keep it short as well, a bit more. We are still a bit over 30 minutes during the lunch break. So.
But the last webinar will be with, we really lucky to have Mark Neze from Nemetschek, who is the Chief Development Officer of the entire Nemetschek group, and will provide a lot of insights on how AI is revolutionizing the software development in the AECO industry. And he will touch also on the sustainability aspect and although the ethical use of AI, because it's a key subject, how our data is used by people who are training AI. So we're very excited to have this one in 2 weeks. And thank you very much, Jaime, for a great presentation as always, and Christophe for chairing that meeting perfectly. Again, thank you everyone for being there. We look forward to seeing you all in 2 weeks. I apologize for my voice, but the 2 days in Saudi Arabia took that toll on us. Thank you.
Thanks a lot,
Thank you, everyone.
Both of you as well for coming today.